Okay, this is a video log for day 362 of the Socklite / day 53 off the grid. So I've been talking a lot about this work on this charge controller and stuff, and it's probably confused most people out there as to what I'm talking about, even maybe people with a slightly more technical background. So, you know, a picture's worth 1,000 words and a video is 25 pictures a second, so this should be worth gazillions of words. So I thought I'd show it. I thought I'd show what I did on day 362. Well, I've been talking about the charge controller and the MOSFET that had gone pop in there, which I've replaced, and the MOSFET on my boost circuit here. Not a boost converter. This is a boost converter. This is just a boost circuit. In other words, it's just boosting the capacity that this can handle by adding basically a slave. Simple as that, really. So I'll show you how that works. The gate signal for the internal MOSFET in here is fed out this connector, which means I can simply trigger an external MOSFET or MOSFETs. I could set up a bank of those if I wanted. There's really no limit to how big I could make this circuit and how many panels it could control. But anyway, what I actually did on day 362 was I basically permatized what I did on day 361. Which means this diode here, the SSR, the 10 amp SSR with the heatsink slapped around it. I soldered it here to feed the source of the MOSFET, and I made this little insulated standoff here out of an old insulation off an I terminal and a bolt. So the diode's just simply sitting there quite nicely in air, because the main diode here does get quite hot and heats up this whole surface. So this one is just heat sinked with its little heat sink, so it needed a bit of air around it, so that's quite nice. And these are the two panels here feed in here that are running from the main diode and through the MOSFET. This is one which is right up on the roof on an angle. This here's the new one that I've ground mounted, but I haven't made a video for yet, so I'll make a video specifically dedicated to that when I get around to it, if I get around to it. What else of note could we say with the circuit? Not taking too long. Right, the original two panels feed in here. Negative. We're talking about the negatives because this is a negative switching regulator, of course. So these are both the damaged ones that I fixed up and did the bypassing and all that stuff. So they feed to this terminal here, and this wire here disappears behind the board and re-emerges here, and it did connect into the regulator itself and was controlled by the MOSFET inside there, but I was having problems with that, so now it's just all going through the boost circuit. So therefore, terminal on there, and it goes to there. Now we've got to remember this is a negative return, so the power is in a sense flowing out of this negative through the MOSFET, through this diode, and returning to these panels, and through this diode, and ultimately returning, boom, to these panels. That's pretty much it. Inside the sleeving there's a 2.2k resistor to stop the MOSFET from being able to draw too much current out of here if that situation occurs, which is unlikely. There's a diode here to make sure that no more than 13 volts, I think it's a 13 volt Zener, could be 12, I think it's a 13, no more than 13 volts gets across between the gate and the source of the MOSFET, because after all the only return is really through these solar panels here, and that overall ground can actually shift a bit depending on the sun and the current and stuff. And I installed a diode inside here to stop any back current that could happen here during a fault or whatever being able to reach the circuit, which meant that there was no way this wire could turn the MOSFET off. So I put a resistor across the gate, which is this little 27k here, and that drains the charge from the gate when this is not turning it on, thus turning the MOSFET off. it would definitely happen a lot slower than a totem pole transistor driver switching between high and low. So there is probably a bit of linear action in this as it goes on and off. When this is PWMing, it's probably a combination of PWM and sort of linear, it's quasi-linear, which normally is not too good for a MOSFET. But this MOSFET's capable of 150 watts, so it can handle it, so I'm not worried about that. As long as the voltage on the battery, which isn't too high at the moment because it's the morning of a slightly overcast day here, and this has been running the fridge all night and the deep freeze for some of the night, and now the deep freeze is chugging away. But this will pick up as the day goes on. Got about 5 amps there at the moment. But yeah, as long as this regulator holds the voltage to the voltages it's meant to be, and as long as the MOSFET doesn't blow up, I don't really care if there's any periods of linear action going on in there. It doesn't worry me. So for all you MOSFET switching purists out there, I think that'll be enough. See you later.